Welcome to yet another class. I'm Dr. B, your chemistry teacher. Today we are going to be looking at something in inorganic chemistry, and that is alkali metals. We are going to look at the alkali metals. The alkali metals. The alkali metals. Now, before I continue, like I have always been saying this, your contribution to what I'm doing here is to subscribe and to share. Remember to share these classes with your colleagues, share these classes with your friends, encourage them to be part of it so that they can build up their IQ in terms of chemistry. Now you also have to let them know that have to subscribe and also have to make comments where necessary. Leave their questions in form of comments. I will attend to them. To like, go to my YouTube, my Facebook page, and also subscribe. Share to your colleagues, your friends in groups to be part of this beautiful thing that we are doing here. And leave your comments and likes as well. Now, we are going to be dealing with alkali metals. Now, there is something very important you need to know, that this is an excerpt from our earlier discussion on the periodic table. Now, do you know that the alkali metals are the S block elements of the periodic table? They are the S block elements, and they are also group 1 metals. Now, let us put down something, a part of the periodic table, to understand what we are talking about. Now, if you look at the periodic table in this form, okay, in this form, you will see that this is hydrogen, okay, and then we also have another. Now you'll see that this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay, let's take it in this direction. And then here we have another. Okay, now this here is hydrogen, this is lithium, this is sodium, this is potassium, this is rubidium, okay, this is cesium, and this is francium. Okay, now this is it. Okay, now this is your group 1, this is your group 2, this is 1, 2, 3, 4, 5, 6, and 7. Of course, this is your period, while across this way is your group. Now, these metals are what build up the group 1 of the S block elements we call the alkali metals. There are 6. Why are they not 7? Why is hydrogen not named among the alkali metals? Because hydrogen only resembles the alkali metals in its electronic configuration, because the alkali metals are always known to have a unit valence. That means they have one valence electron at the large s orbital. The same thing goes with hydrogen. That is the only resemblance. Under normal temperature and pressure, hydrogen will always exist as a gas. Except at extreme temperature, it begins to show a little characteristics or properties of the group 1 metals. That is why hydrogen is not always considered as what a group 1 metal, because it does not show much characteristics of group 1 metals. It rather exists more as a gas, except that it possesses the electronic configuration of group 1 metals. I'm sure you learned something important today why hydrogen is not counted among the group 1 metals. So the group 1 metals that form the alkali metals are lithium, sodium, potassium, rubidium, cesium, and francium. Okay, I wouldn't want to bother myself by writing their names, but just go to your table and you'll see that this is lithium, sodium, potassium, rubidium, cesium, and francium. Now these are the alkali metals. Now, as alkali metals, what are they? There is need for us to know that alkali metals that belong to the group 1 of the periodic table are the S block elements. We said that before. They are the S block elements. Okay, and these alkali metals are what? They are reducing agents. Do not forget that they are reducing agent. They are reducing agents. And we say that as you move from the top of the table, coming down the group, the reducing tendency does what? The reducing tendency increases. That is, there is increased reducing tendency. So francium is more a reducing agent than cesium, and cesium is more a reducing agent than lithium. But all of them are reducing agents. Now, this particular reducing agent has a larger atomic radius as you move down the group. So francium has a larger atomic radius than lithium. And they have also a reducing ionization energy. So you see that they have large atomic radii. They have low ionization energy. Okay, you can see that. Now, because of the large atomic radii and the reduced ionization energy, these particular alkaline metals are always very reactive. They are always very reactive. Know what I said? Because the alkali metals possess large atomic radii and low ionization energy. Especially, they have a large ionization radii as you move down the group, and they have a low ionization energy as you move down the group. It makes them very reactive. So they can form compounds with non-metals. And these compounds they form with non-metals are always in an ionic bonding nature. So these alkali metals always form what? Always form compounds that are alkaline compounds with non-metals, and they are always exhibiting ionic bonding. So they exhibit what? Ionic bonding. That is the beauty of alkaline metals. And do you know that because we term them as alkali metals, they show characteristics of metals. Yes, they show characteristics of metals. Now that means that they have a sort of high thermal conductivity. Yes, they have high thermal conductivity. They also have high electrical conductivity. They have high thermal conductivity, they have high electrical conductivity because they are metals, so possess characteristics. They are lustrous. Okay? They are lustrous. They are also malleable in nature. Okay? They are malleable. They are ductile. They are lustrous. Okay. All these properties makes them to be called metals. So alkali metals are what? They possess characteristics of metals. So they have high thermal conductivity, high electrical conductivity. They are malleable, they are ductile, they are lustrous. Lustrous means they are shining. Now, something that actually characterizes these very alkali metals, apart from these qualities we put down here, is the fact that they carry just one valence electron. They have a unit valence. They have one valence electron only at their outermost S shell. And that is why, for example, sodium that is 11 has 1s2, 2s2, 2p6, and 3s1. You can see that sodium has 3s1 with just one valence electron at the outermost shell, and that makes them very reactive. The reason why they can always form compounds with non-metals and form alkaline solutions. Now, if you take a look also at lithium, lithium is 3, so 1s2, 2s1. You can see it. So all the alkali metals has one valence electron at their s orbital, and that particular reason shows that they are very, very reactive. They can give out that one electron, and that is also consequence upon the fact that their ionization energy is low. Ionization energy reduces as you move from right of the period across the period to the left, and also reduces as you move from top of the group of this alkali metal down the group. So it means that francium and calcium, as you go, are more reactive because they have a larger ionic radius and have also a lower or the lowest ionization energy. So it is easier for their loosely bound 1s orbital, the valence electron at the s orbital, to easily leave them to form compounds with non-metals. That is very important and very interesting. You can see the chemistry of the alkali metals. Now, it is also interesting for us to know that apart from these particular statements that we have made concerning the alkali metals are very reactive. We have agreed, we have confirmed that and affirmed that. But the alkali metals, as they are, appears to have certain reactivity. Their chemical reactions or chemical reactivity seem to be a little bit very different amongst themselves. Now, let us take a look at their reactivities. Let's take a look at their reactivities. Do you know that the alkali metals react with oxygen? It's important for us to know that the alkali metals react with oxygen. Yes, it's important for us to know that as they are very reactive, alkali metals are not good to be allowed to be exposed to air, whether oxygen or air. We are saying the same thing. Because once they are allowed to be exposed to air, they quickly run into reactions. So usually they are always being stored. For example, because of their high reactivity with oxygen, lithium is always being, now you look at lithium and sodium, and to some extent potassium, okay? Lithium, sodium, and to some extent potassium are always stored in oil. Okay, they are always stored in oil. This is because of their density. They have a lighter density, so because the density of these metals are increasing as you are moving down the group. So the lithium, sodium, and potassium, because of their light density, they are always stored in oil. Okay, you can see. Now, they have light density, okay, and less reactive. They have lighter density and less reactive. But if you see potassium again, potassium, rubidium, and calcium, they are always stored in a glass. Okay? They are stored in glass tubes. Because they have larger densities and are highly reactive. Because of what? Because of their reduced ionization energy and their increased atomic radii. So potassium, rubidium, and cesium are always stored in a glass tube where air can never have contact with the metal. Now, oxygen is always reacting with this metal. For example, if you look at oxygen reaction, these metals will always, alkali metal will always react with oxygen to form oxides, which are usually monooxides, okay? They form oxides, which are usually oxides 2 minus there, and then they also form peroxide. They form peroxides, okay? They also form superoxides, which we can say, okay, they form superoxides. They also form ozonides. Ozonides, they form ozonides. Okay, you can see. So you see that these alkali metals always form oxides, peroxides, superoxides, and ozonides. These are the reactions. And these reactions are reactions that come out with heat, and that is why alkali metals are always seen to be metals that give out very heavy amount of heat. And because of that, their reactivities are always seen as being exothermic in nature. So the alkali metals are always exothermic in nature in their reactions because they give out heat. And this heat used to come out in the form of the hydrogen gas that is given out. Now, so if these alkali metals react with oxygen, they will form oxides, peroxides, superoxides, and ozonides. And usually, lithium is what forms the oxides. Lithium is what forms the oxides. Okay, like lithium oxide. So you can have an example here, like if this is lithium. Okay, so lithium is what used to form that oxide. And then sodium, potassium, they form peroxide. Sodium, potassium form peroxide. So you could have sodium peroxide. You could have potassium peroxide. So usually sodium and potassium forms what? Peroxides. And then you also have rubidium and cesium that used to form superoxides. And then we have also ozonides that are formed. That is the reaction of alkali metals with what? With oxygen. Now, that is not enough. We also have alkali metals reacting with water. But it's important for us to know that alkali metal reacting with water is like you turning water into an acid. Yes, water. Their reaction with water, alkali metal reacting with water. The alkali metal react with water is more like you turning water into acid. Those reactions are always coming with explosions. They create the exothermic reactions, but they are always they generate very high heat. So when alkali metals react with water, it reacts vigorously. So they release high amount of energy that sometimes it gives out an explosion. So always be careful when you are dropping a sodium metal in water. It is always very, very dangerous because it could give out an explosion at the end of the day. Now they can react with water to give out what? To give out hydrogen gas and sodium. And of course, you know that they form alkali. So if this, for example, was a metal, an alkali metal, okay, reacting with water, so we expect to have the alkali metal forming hydroxide plus plus the hydrogen gas. Okay, so usually always when a metal from the alkali metal group reacts with water, it gives off a hydroxide, and then with the hydrogen gas, as a consequence of that reaction. And like I said, the hydrogen gas is always very reactive because it allows for more increased heat, and sometimes it comes with an explosion. Now, it is also very important for us to note at this point that this particular reaction goes a long way to also explain what happens with alkali metals in other solutions. Now, do you know that you can identify the concentrations of alkali metals in solutions through the color they give when in flame? That is a qualitative analysis test in analytical chemistry. You can see that water is a solution, but in other solutions too, you can identify the concentration of alkali metals present in a particular compound when you bring flame to it. Now, if you carry this salt, an alkali metal salt, and then you dip it in a solution, let's say concentrated acid, for example, and you take it to a flame, you get a particular color coming out of it. For example, if it is lithium, if it is lithium and you take to flame, you will see a red coloration. You see a red coloration. That means that the salt you carry contains what? A larger concentration of what? Lithium ions, which are what? Alkali metals. Do you also know that if it is sodium, it will give you a bright yellow coloration? Once you take a salt you don't know and you dip it in a particular solution, like maybe an acid, for example, HCl, take it to a flame. If it comes out with a large amount of yellow coloration, a bright yellow color, know that it is what? Sodium salt. There is a sodium salt in there as an alkali metal. If it is potassium, it will give you a lilac color or a violet color. A violet color. Okay. Then if it is rubidium, rubidium will always give you a red coloration. Okay. And then cesium will always give you a blue coloration, just like you have with copper. Okay, so once you take any of these salts and then you dip it in any solution, especially an acid, and you take it to a flame, you have these colors show. And once these colors show, know that this is the kind of alkali metal that is present. That is reactions of alkali metals with water. How about alkali metals reacting with alloys, with non-metals, for example? Now, I want us to know that alkali metals can react with non-metals. All alkali metals react with non-metals, but lithium reacts with nitrogen. Only lithium among all the alkali metals that react with nitrogen. That is what makes lithium very, very, very exceptional. Lithium behaves a little bit like the group 2 metals that are the alkaline earth metals. So lithium possesses a tendency, unlike other alkali metals, to react with nitrogen, and that is the only non-metal, alkali metal rather, that reacts with non-metal, which is nitrogen. Only lithium reacts with nitrogen. And lithium also has another characteristic that makes it looks like it is a group 2 metal. Lithium forms very stable hydrides, but every other non-metal forms an unstable hydride that is very reactive. But lithium metal forms a stable hydride. Lithium metal forms also a lithium carbide, that is carbides. Okay, it forms carbides. So lithium metals form carbides. So you can see lithium CC. Okay, let's say this. So lithium form carbides, just like calcium can form calcium carbide. Lithium also form lithium carbide, and that is why lithium is always seen as possessing characteristics of the group 2 metals and not the group 1 metals. So lithium is very exceptional among all the group 1 metal, which are the alkali metal. Lithium is very exceptional. Like I said, lithium reacts with a non-metal, which is nitrogen. Only lithium reacts with nitrogen among all of them. Lithium form carbides like calcium. Lithium also form very stable hydrides, and that makes lithium very different from the group 1 metals, but it rather resembles the group 2 metals. I'm sure we have learned something today from alkali metals. We've spoken a lot already. Let's not overstretch these alkali metals. You could read more on by yourself at your quiet times. Do not forget to share. Do not forget to like. Most importantly, don't forget to share these videos with your colleagues, friends, so they could be part of it, and tell them to try to subscribe so that they can always be receiving the videos once they drop. And do not forget also to go to my Facebook page, and that is Dr. B Chemistry Class, and subscribe, or rather follow, and then share also to your friends and your colleagues. Like